Math 107, Final Exam Review, questions 19 and 20. Question 19. Find the domain of the function f of x equals x minus 2 over 3x squared plus 4x minus 15. All right, the domain is any number that you can insert into the equation that will create a real number answer. All right, the only numbers that will not create a real number answer are numbers that make the denominator equal to 0. So what I need to do is I need to factor 3x squared plus 4x minus 15. Because of the 3, I'm going to use the AC method. I'm looking for numbers that multiply to AC and add to letter B. A times C is negative 45. Letter B is 4. So numbers that multiply to make 45 that are 4 apart are 9 and 5. And I want the 5 to be negative because the higher digit has to be positive. All right, I'm going to insert those numbers in either order. I'm going to put the 9x first, negative 5x second, minus 15. With 4 terms, I'm factoring by grouping. If I put the 9 in the front, I'm taking out the greatest common factor. The highest number and letter that goes into both is 3x. When I divide by 3x, I get x plus 3. X plus 3 is further down the road. To create an x plus 3, I have to remove a negative 5. My two binomials are 3x minus 5 and x plus 3. Now, since I do not want the denominator to be 0, I'm going to use the zero product rule to establish what numbers I cannot choose for my domain. If I use the zero product rule for the first one, the pattern is opposite sign, right over left. I would get numbers that are 5 over 3 and negative 3. So my domain is all real numbers, all reals, except 5 over 3 and negative 3. Number 20. It says perform each of the following operations and simplify the results. This is a multiplication because of the dot. I'm taking one rational expression and multiplying it times another. All I need to do is to factor and simplify when I'm done. In the first one, the numerator is x squared minus 2x. The only thing that I can do is take out a greatest common factor. If I divide each of these by x, I'm left with x minus 2. In the denominator, I'm looking for numbers that multiply to negative 3 and add to negative 2. Those numbers are negative 3 and positive 1, x minus 3, x plus 1. In the second one, I'm going to take out a 2, and I'm left with x minus 3. And in the denominator, I have what's called a difference of two perfect squares. So I take the square root of the front, the square root of the rear, and I use opposite signs. Square root of x squared is x. Square root of 4 is 2. One's plus, one's minus. And all I'm doing when I'm multiplying these two fractions is I'm really pushing them together and just reducing. I have an x minus 2 on the top and the bottom, an x minus 3 on the top and bottom. And then all that remains is 2x over x plus 1 and x plus 2. Now make sure that you never reduce part of a sum or a difference. So do not reduce anything that's separated by a plus or minus sign unless you can do it on the top and the bottom. All right, for division, letter B, this time the extra step for division is that I have to flip the second fraction. So the first one is going to be 3x minus 2 over, I'm looking for numbers that multiply to -6 and add to 1. Those numbers are 3 and -2, x plus 3, and x minus 2. 3 and -2 do in fact add to 1. So in the numerator, I'm going to flip this, so the 2 minus x will be on the top, and the x plus 4 will be on the bottom. So x plus 4 is on the bottom. Now, you can rearrange, it's legal to rearrange an expression, so it would be -x plus 2, and then you can divide each of these by -1. So if I take a -1 out, then I am changing the signs. It's like taking out a greatest common factor. Change the signs of everything, divide by -1, and you get x minus 2. All right, the x minus 2, because remember these are joined, x minus 2 reduces with the x minus 2 below it. And then I have -1 multiplying 3x minus 2. And this is over x plus 3 and x plus 4. All right, the next one we are adding and then subtracting two rational expressions. When I add or subtract fractional polynomials, I have to make sure that I have a least common denominator. Whoa. My least common denominator is one of every thing in the denominator. So the LCD would be x minus 2, x minus 3, and x minus 4. Okay, because you need the highest amount of each part. All right, so to create the LCD on the left, I need to multiply the top and the bottom by what is missing. And when you look at the denominator, we are missing the x minus 4. So I'm going to have x minus 4 times the -x plus 1. On the right, what is missing is the x minus 3. So I'm going to multiply the current x by x minus 3. I'm going to multiply and condense. I would have from the left x times -x would be -x squared, I'm foiling, plus 1x. Negative times negative is positive 4x, and then -4. If I distribute in on the right, I get x squared minus 3x. All of this is over the same denominator, so I'm just going to go ahead and add like terms, and then I'll put everything on top of the LCD. So we're crossing out the x squared. We have 4x plus 1x is 5x, minus 3x is 2x, minus 4. I can take out a greatest common factor, which is 2. And then I have x minus 2. This is all over x minus 2, x minus 3, and x minus 4. The x minus 2's reduce. Whoa. And my final answer is 2 over x minus 3 and x minus 4. Letter D is very similar, only I am subtracting. So I'm going to have to be careful of my signs. And I actually need to factor the right-hand side denominator in order to establish the LCD. That's a difference of two perfect squares. So when I factor it, I get x plus 1, x minus 1. So my LCD is an x plus 1 and an x minus 1. On the left, what I have to multiply by what is missing. And what is missing is the x minus 1. So we have 2 times x minus 1 all over. We had an x plus 1, and we added an x minus 1. Minus, the second one is x minus 3, and that is over the original x plus 1 and x minus 1. Once you have the LCD established, then you just combine like terms in the numerator position. You have 2x minus 2, and this subtraction, I'm going to change this. I'm watching my signs very carefully. I'm going to change it to addition and change the signs behind it. All right, so that becomes 2x minus 2 minus x plus 3 gives me 2x minus x is 1x. Negative 2 plus 3 is plus 1. And this is all over x minus 1, x plus 1. The x plus 1's cancel. And I'm left with, when there's nothing on top, there still is a 1. So we have 1 over x minus 1.